No tangled cables, no fumbling for ports in the dark, just a simple placement, and your phone quietly, effortlessly, begins to draw power. It feels like pure magic, energy flowing through thin air. But how does your smartphone, without any physical connection, actually pull electricity from a charging pad? What invisible force bridges that gap, bringing your battery back to life? This isn't sorcery, it's a centuries-old principle of physics, harnessed by clever engineers to power our modern lives. It's a fascinating dance of electromagnetism happening right beneath your device. Welcome to the Smart Side, the channel where we unravel the ingenious science and hidden processes behind the everyday. Today, we're exploring the surprising truth of how your phone charges wirelessly, transforming invisible waves into vital power. To understand wireless charging, we have to go back to the 19th century, to a groundbreaking discovery by a brilliant scientist named Michael Faraday. He found that if you move a magnet near a coil of wire, it creates an electric current in that wire. And conversely, if you run an electric current through a coil, it creates a magnetic field around it. This fundamental principle is called electromagnetic induction. Fast forward to today, and your wireless charger uses this exact same magic. At its core, you have two main components: a transmitter coil inside your charging pad, a receiver coil inside your phone. Think of it like a conversation between two unseen magnets. Here's the precise choreography. Generating the field. When you plug in your wireless charging pad, an alternating current, or AC, flows through its internal transmitter coil. This rapidly fluctuating current creates a time-varying magnetic field around the coil, pulsing outwards like invisible ripples through the air. It's constantly changing in strength and direction, capturing the energy. When you place your compatible phone onto the pad, its internal receiver coil enters this invisible, pulsating magnetic field. According to Faraday's law, that changing magnetic field induces an electric current in the phone's coil. It's like the pad's magnetic field is giving the phone's coil a gentle, rhythmic push. Converting to power. The induced current in your phone's coil is an alternating current. But batteries need direct current or DC to charge, so a tiny component inside your phone called a rectifier quickly converts that AC into DC. Charging the battery, this rectified DC current then flows into your phone's battery, bringing it back to life. This entire dance happens seamlessly, power transferring from one coil to another, bridging that tiny gap of thin air. For this invisible transfer to work reliably across different brands and devices, a common language was needed. That's where the Qi standard comes in. Developed by the Wireless Power Consortium, Qi, pronounced Qi, is the most widely adopted universal standard for wireless charging. It ensures that your iPhone can charge on a Samsung Pad, or your Google Pixel can power up on a generic charger, as long as they're both Qi certified. But even with Qi, alignment is key. The closer and more perfectly aligned the transmitter and receiver coils are, the more efficiently the energy transfers. A slight misalignment can mean slower charging and more wasted energy as heat. Modern chargers also include smart safety features like foreign object detection, FOD. If you accidentally place a metal object like keys or coins between your phone and the charger, the system will detect it and stop the power transfer, preventing dangerous heat buildup. Apple's MagSafe takes this a step further, using magnets to automatically snap your iPhone into perfect alignment, optimizing charging speed and efficiency. While incredibly convenient, current wireless charging technology still has its limitations. It's primarily designed for short distances, typically just a few millimeters to a few centimeters. The further apart the coils are, the more energy is lost as heat, making it less efficient. However, the future of wireless power is constantly evolving. Researchers are developing resonant wireless charging, which can transmit power over slightly greater distances, a few feet, allowing for more flexible placement. Even more ambitious concepts like RF, radio frequency, wireless charging, which could one day charge devices from across a room, though at much lower power levels currently. The vision is seamless integration. Furniture that charges your devices as you set them down. Public spaces where power is simply in the air, and even electric vehicles charging wirelessly while parked or driving. So the next time you drop your phone onto its pad, remember the hidden ballet of physics at play. It's not magic, but the ingenious application of electromagnetic induction, a universal standard, and smart safety features. From Faraday's early experiments to the sleek devices of today, wireless charging is a testament to how human curiosity continues to transform invisible forces into effortless convenience, truly charging your life through thin air. Were you surprised by the science behind wireless charging? What other invisible technologies or hidden everyday marvels do you want us to unravel on the smart side? Share your thoughts and curious questions in the comments below. If you found this explanation enlightening, smash that like button to support more smart content, share it with a friend who's still fumbling with cables, and make sure to subscribe to the smart side for more mind-blowing discoveries. Stay smart and power up wirelessly.